Okay, we're continuing with the section 5.3 mass. And let's just read the slide. Mass is a property that specifies how much resistance an object exhibits to changes in its velocity. We can substitute the word inertia in there also, because inertia is related to mass. The more mass something has, the more inertia it has. So let's imagine playing catch with a basketball or a bowling ball. Which ball is more likely to keep moving when you try to catch it? Basketball or a bowling ball? Well, the bowling ball. I don't know that I'd want to play catch with a bowling ball. Which ball requires more effort to throw it? Well, once again, the bowling ball. The bowling ball requires more effort. It has more mass. The bowling ball is more resistant to changes in its velocity than the basketball. It has more inertia. So the mass is the property that specifies how much resistance an object exhibits to changes in its velocity. The more mass something has, the more inertia it has. Experiments show that the greater the mass of an object, the less that object accelerates under the action of a given applied force. Experiments to compare acceleration given a force produces a different acceleration. So a force acting on an object of mass m1 produces an acceleration of a1. The same force acting on an object of mass m2 produces an acceleration a2. The ratio of the two masses equals the inverse ratio of the magnitudes of their acceleration. So m1 over m2, the ratio of it is a2 over a1. So as an example, a force acting on a 3 kilogram object produces an acceleration of 4 meters per second squared. And the same force applied to a 6 kilogram object produces an acceleration with half the magnitude, 2 meters per second squared. Now, the magnitude of acceleration of an object is inversely proportional to its mass when acted on by a given force. If one object has a known mass, then the mass of the other object can be obtained from acceleration measurements. Now, mass is an inherent property of an object, independent of the object's surroundings and of the method used to measure it. It's a scalar quantity. So as we go to, well, let's just continue here. Mass and weight are different. We use them interchangeably. In fact, we have a ratio, how many pounds are in 1 kilogram. We equate the two, but really pounds is weight and kilograms is mass. So they're two different animals. The weight of an object is the magnitude of the gravitational force exerted on an object, and it varies with location. For instance, a person weighing 180 pounds on Earth weighs only 30 pounds on the moon. They have the same mass, but their weight is different because the weight is dependent on gravitational acceleration. So the mass of the object is the same everywhere. The object having a mass of 2 kilograms on Earth also has a mass of 2 kilograms on the moon. Now, this is a single slide discussion, so this ends our discussion of mass. Next, we will describe Newton's second law.